Hi everyone, welcome to today's class. Today we have a very nice math challenge on the board, a very nice exponential challenge. The question is to solve for s from this. So how do we solve this? On this channel, I've already solved a similar problem, okay? And the question is showing up here. In that video, I used two different methods to solve for the value of x. Do it to watch that video so that you can get the two various methods are applied in solving that challenge. So if you're new here, this is Online Maths TV where we learn mathematics all the time. If you're not subscribed, subscribe and turn on notification bell so that you get notified whenever we drop an amazing video like the one we're about to solve right now. With that being said, let's go into our challenge for today without wasting of time. All right. So we take our solution. All right. So now what I'm going to do here now is very easy. I'm going to take the content inside this radical, multiply by the content inside this radical also. So here we're going to have here your 3 plus 2 root 2 close bracket, your 3 minus 2 root 2, right? Now, if you open up this will give us 1. That will give us 1, okay? If we use this to open this, because this is a conjugate of this. Do you get that? So if it is a conjugate, definitely we're going to have 1 from here. Then what I'm going to do here now is this. I want to make 3 minus 2 root 2 the subject of the formula. In other words, I want to divide by this. So I will now divide everything here by 3 plus 2 root 2. Okay, so long I'm doing that to the left hand side, I must do that to the right hand side also. So we have 3 plus 2 root 2 also. So this and this will leave. So I'm now left with 3 minus 2 root 2 is equal to, let's put this in bracket, is equals to 1 all over 3 plus 2 root 2. Okay. Now, what we do next here? It is easy. You now discover that this quantity is same thing we have here. And this is equal to this. So we can put the whole of this quantity in place of this. So I want to rewrite the original equation. So rewriting the original equation, we now have this to be our square root of your 3 plus your 2 root 2 all to the power of x plus here we're going to have the square root of 1 all over this. Because what we have here now is this. So we are putting the whole of this, in place of this. So all over 1 over 3 plus 2 root 2. So everything is raised to power s. So everything raised to power what? X. Easy. Now let's look at this very well. From solve, we can take the square root of this separately, take the square root of this separately. So we can rewrite this again as our bracket open the square root of 3 plus 2 into the square root of 2, okay? The close bracket all to the power of x plus 1 all over the square root of 3 plus 2 root 2. Close bracket or to the power of x. Again, we can use this to open up this. And this x will be raised to this power here. So let's go ahead and rewrite this expression again. So rewriting this, we're going to have our expression to be bracket the square root of your 3 plus 2 root 2 or to the power of x. There plus, here we have 1 all over your square root of your 3 plus 2 root 2. Okay, let's close up this well. Okay, bracket all to the power of x, everything equal to 6. Okay, sorry, yeah, it's equal to 6. Let's take it down here, everything equal to 6 here. So what we do here now, we now discover that what we have here is same thing we have in here. All right, so from here we can now say let's use p be equal to the square root of your 3 plus 2 root 2 r to the power of x. Easy. So Whenever we see this expression, let's put in p there. So here we're going to have this. This now implies that our p plus 1 all over p equal to 6. So eliminate your p. So this will give us p squared plus 1 equal to 6p. Rearranging, we have p squared minus 6p, then plus 1 equal to 0. Now, this is a quadratic equation where we're going to solve quadratically, right? Okay, so yeah, let's use the quadratic formula. Using the quadratic formula, we're going to have our p is equals to minus b plus minus the square root of b squared minus 4ac all over your 2a. So what is our a? Our a is equal to the coefficient here, which is 1. B is equal to minus 6. C is equal to positive 1. Okay, so let's substitute into this and see what P gives us. So P we have here minus, our B is minus 6, close bracket, plus minus into the square root of minus 6 r to the power of 2 minus 4 times 1 times 1 again. Okay, everything all over 2 times 1. Okay, so if we open up this, will now give us here 6 plus minus the square root of 36, then minus 4 all over your 2. So let's continue on this side, see what this gives us. Okay, so we're going to have P is equal to, here we have 6 plus minus the square root of this from this will give us 32 all over 2. Now 32 can be expressed as your 16 times 2. And the square root of 16 is 4. So we can rewrite this as our 6 plus the square root, 4 into the square root of 2 all over 2. So if we use 2 or we factor out 2 here, then this expression will now give us P is equal to 3 plus minus 2 root 2. So we have P1, P2 here now. So the first one will take the positive sign, the second one will take the negative sign. And so from here, let's take case 1. Case 1, for the first one, when we have your P1 is equal to 3 plus your 2 root 2. So what do we do here now? Now we go to where we said, let P be equal to this. So if we are saying P is equal to this and we are solved for P for this, so for your case 1, we are going to have this to be a bracket, your square root of 3 plus 2 root 2, okay? Close bracket, out to the power of x, this is equal to 3 plus 2 root 2. So what do we do here? Now take note of this. You discover that what we have in here is same thing we have here. So let's put this in bracket. We have to eliminate this radical by writing out this radical. So we can rewrite this as your bracket 3 plus 2 root 2 into x all over 2, right, is equal to your bracket, your 3 plus 2 root 2. So squaring both sides of the equation, what happens? This will leave the system and square will come here. So we now have this to be 3 plus 2 root 2 r to the power of x is equal to the 3 plus 2 root 2 r squared. So the bases are now the same. So we cannot strike this. We equate the exponent. So x is equal to 2. This is the first value of our x. Okay? So this exponential challenge. So how do we solve for the second values of x? Let's erase here and see what the second values of x will give us. For your case 2, which is going to be p minus, so we have p is equals to your 3 minus 2 root 2. Again, we know that our p, we said let p be equal to this. So this now implies that our bracket square root of 3 plus your 2 root 2 r to the power of x is equal to your 3 minus 2 root 2. Close bracket. Okay. Now, what we do here is easy. How do we manipulate this? Recall when we made this the subject of the formula? Look at what we have here. So we can rewrite this side of the expression. So this will now give us here your bracket is square root of 3 plus 2 root 2. Okay? R to the power of x is equal to 1 all over what we have here. Where is it? What we have here, right? So we have here bracket 3 plus 2 into the square root of 2. Close bracket. We apply the law of indices by removing this one and this division sign. So this will now give us here square root of your 3 plus 2 root 2. Okay? Close bracket to the power of x is equals to bracket your 3 plus 2 root 2 raised to power minus 1. Easy. Okay, so again, we eliminate this radical. We take the square of both sides. So if you square both sides, like we did the other time, so this will now give us here the root 2, the close bracket to the power of x is equal to bracket 3 plus 2 root 2 all to the power of minus 2. So the bases are the same. So we can equate the exponent. So this leaves. So we now have our x is equal to minus 2. So this is the second value for our x. So in all, we have our x1. x1 is equals to positive 2. x2 is equals to negative 2. So these are the two roots that will satisfy this nice exponential challenge. So this marks the end to this simple challenge. If you learn something from this video, give the video a thumbs up. And if you have a better way of solving this challenge, drop it in the comment section. Okay. Again, this is Online Maths TV. Do well to subscribe. And when you subscribe, turn on bell notification button so that you get notified whenever we release more wonderful videos like this one. Okay. Again, I love you, and all of us at Online Maths TV loves you dearly. Bye for now.